Okay. Um, Good morning, everyone. It's with great pleasure that we have these distinguished panelists to join us today to explore a very broad, very rich, and very, I think, timely theme of discussion. So today we're talking about human well-being and sustainability from a physicist perspective. So as introduced, I'm Yvonne. I'm an assistant professor. I think I still fall in the category of young scientists here. And with me, we have four very, very distinguished guests in this discussion. So I think they need very, very little introduction, especially if you're a physics person. But still, we'll go through the notion, and I'll give each of them a few minutes to introduce themselves, but also maybe tell us a little bit about one physics discoveries in their lifetime that they find the most exciting. And then we'll kick off the discussion from there. Okay? Kostya, please.
Right, it's a great pleasure to be here. Thanks a lot. And I'm Konstantin Novoselov. I'm a professor of physics and material science at the National University of Singapore. I'm a director of the Institute for Functional Intelligent Materials. I've been working a lot on two-dimensional materials like graphene, and so these days we're trying to work on materials out of equilibrium, materials which can be which can interact actively with the environment. And that's actually just coming back to your question about the most exciting discovery. I think that well, we were talking here and just wondering why five physicists have been asked to comment on climate, and then we quite unanimously decided that everything around is physics indeed, and that's exactly what we're trying to figure out these days, is how the mechanics and quantum mechanics are linked to the to thermodynamics, and how all those two linked to the biology, and how can we explain the living systems from the point of view of physics. And for me, that's one of the most interesting topics which hasn't been addressed much, and addressed by some people, but not up to but not exhausted certainly. And I think the most exciting discovery is still ahead.
Thank you. And Brian, what about you?
Hello. Brian Schmidt, I grew up, and didn't say this in my talk, but grew up in Alaska and Montana in the United States, so the cold part of the United States, very remote. And I've been in Australia since 1994. And I guess if I look at, and I've had a chance to do many things, not as many as Stephen next to me, but I'm trying to catch up. I got another decade to try to catch up with Stephen. I run a vineyard and a winery. Stephen hasn't managed to do that yet, but give him time. And so I was until the end of last year the vice chancellor or the president of the Australian National University, which was interesting, not quite the Secretary of the Department of Energy, but it was the closest thing I could find in Australia to do. So from my perspective, astronomy has been in a kind of a tsunami of excitement during my lifetime. I've been very lucky to be part of it. And I think the discovery for me that I found the most remarkable was the discovery of gravitational waves. And the reason I find that so amazing is, they go right back to 1917, when Einstein realized that gravitational waves were a prediction of his theory, but he said, you'll never, ever be able to measure it. And sensibly, you should have never been able to measure it, but we are able, through advanced techniques developed over 100 years of physics, including work by people in this room, able now to literally measure the distances between point A and point B to about 10 to the minus 18 meters, which is well less than the radius of an atom. And by doing that, we have been able to see these kind of ripples in space caused by the mergers of black holes. And not just a couple, but thousands of them now. And I just think that 100-year time span really embodies the remarkable way that physics is able to make progress. And it should give us hope about how we actually can go through and do remarkable things that seem impossible if we put our mind to it for a long period of time in a positive way. And I think it's a great example of physics doing exactly that. Thank you.
Thank you. And Steve?
Well, I'm a professor in the physics department at Stanford University and also in molecular cellular physiology in the medical school. And Stanford recently started a new school in environmental sustainability. And I'm a member of a new department there called Energy Science and Engineering. As I dabble in a lot of things, you've heard it's partial sampling of some of them. Now let me move on to what I think the most important thrilling discoveries are in my lifetime. I would actually concur in part with what has been happening in high energy physics / astronomy / cosmology. It's breathtaking, but I also think that based on physics methods, diffraction as a start, but then electron microscopy, we have great strides in structural biology, molecular biology, and I think there's a glimmer now where we can understand how these things work at a real physics level, not at a descriptive biology level or descriptive biochemistry level, but in terms of real physics principles where you can make a mathematical model that's quantitative and falsifiable, and that we will know enough about these things that we can do this. The other thing I think is amazing is that we're beginning to understand how a very complex system, the Earth's climate, works. And if you ask many, many physicists 3 or 4 decades ago, it was a common feeling, no, it's too complicated. And very famous physicists, Freeman Dyson, among others, said, no, it's way too complicated. You're trying to talk about effects at the 1% level change that you're saying could have profound effects on how the Earth evolves. And yet, after these many decades, it's looking like we're beginning to understand things at great detail, which is amazing that such a complex system could be understood, and it has to be understood because if we wait for it to happen, it will be too late. And so I think that's another big breakthrough in science.
Great. And Duncan?
Well, I've always, of course, been impressed by things that Brian has done, for example, the dark energy discovery and the gravitational waves. They're really amazing things. But in the area I'm working in, I've always been surprised by the unexpected things that quantum mechanics can do. And perhaps for me, the most unexpected and still mysterious one is the fractional quantum Hall effect, which made a huge impact on me because
Duncan?
all the techniques that we'd been using for many body physics, all the fancy theoretical techniques, which before this discovery we thought would do everything we wanted to do, like Feynman diagrams, all this nice stuff, was completely useless for this new twist that quantum mechanics threw at us. And it taught us that we have to develop new ideas as when new things show up. And one can never be complacent. But I think that quantum mechanics still has a lot to deliver, and just especially understanding how information diffuses and flows. Yeah.
Thank you. That's something very close to my heart as well, on quantum information. And that's what we're, actually, we do a lot of that here in Singapore, building devices to probe effects in quantum physics and understand how to better encode and process information. So I think you've all had your favorite pick, and this is very interesting because I think a lot of what you said is very interdisciplinary, right? It's from a physics perspective, but it also touches on many other related fields, from environmental to information to biological, etc. And I think that's really very much in connection with the theme we're exploring today, right? So sustainability is a very multifaceted word. I think you can think about sustainability in many different ways and different directions. So perhaps to kick off the discussion, I would ask you to tell us a little bit what sustainability mean to you, and how do you think, as a physicist, we can contribute to bringing or promoting sustainability for in the world or for human well-being in general. Okay, so that's quite a loaded question. So perhaps we can just start by maybe what sustainability mean to you specifically. Perhaps we can start with Stephen.
Well, it means I'm not sure. Word sustainability is said a lot. You think sustainability mean it can go on forever? I don't think so, for a number of reasons. The astrophysicists tell us in a couple billion years, the Earth will warm too hot and life will perish.
It's quicker than that, my friend.
Within a billion years. It doesn't have to roll before red giant. But I think, we're using up Earth resources. And so when people talk about sustainability, these are finite resources. You say, can you use them more efficiently, less slowly? But in the end, I will say the fundamental thing is we've gone from a world where we're at 8 billion people. We're going to be going to 10 or 11 billion by this end of this century. And we have economists that say you want to encourage people to have more children to keep going the Ponzi scheme. What's the Ponzi scheme? You have more young investors, fewer old investors, and so you keep this going. If you have more young people to take care of fewer older people, you don't have to be efficient. And yet, how can you have more and more people demanding more and more and extracting more and more out of the earth? It's crazy. Now, there's a natural birth control going on. As soon as people get even to be middle class, or even not even, India's birth rate among fertility among women is like 2.2. 2.1, 2.05 is break even. Most developed countries are less than 2. Korea's 0.7, Japan's 0.8, 0.8. And so there's a natural birth control going down. So can you have a rising prosperity and let the natural urge to have fewer children as you get more well-to-do and middle class, and don't listen to the economists? But what do? As you go to more and more automation, you actually don't need as many jobs. And so one of the things is, how do you gracefully go into having rising prosperity with fewer people? And you can't talk about sustainability until you figure that out and you make it a reality. And this is automation, this is robots, this is all these other things.
Right. I think that's a great direction. I think, Kostya, you also earlier brought up this topic about intellectual sustainability, right? Along the same line, like with automation, robots, perhaps machine learning, AI taking place more and more so in the society. How does that contribute or affect our notion of sustainability?
Yeah, I don't want to be completely unpopular in this audience, but I guess we bring a lot of those problems on ourselves, and humanity always plays this whack-a-mole game, so that we create something new and then we need to figure out how to mediate the consequences. So we figured out that we can burn oil. Now we have to do something with the CO2. We produce a lot of silicon solar panels or lithium-ion batteries. We need to figure out how to recycle that. And for that, we invented this term of the circular economy, which unfortunately doesn't work because there is always entropy. So there is from the second law of thermodynamics, you can't create the circular economy. So then that's what Stephen was mentioning. So we have to go beyond that. We have to create the spiral economy and to make more younger people working on those solutions and so on. So far, and basically sustainability and good sustainable solution is a solution which would allow us to escape from this vicious cycle I mean, so that's again your example of the AI. Just it's a great example. It's increases productivity, but in terms of energy demand, it really strains us a lot. And so, how to find those technological solutions which do make our life better, but again, don't strain our resources, or if it is fundamentally possible at all, and it's fundamentally impossible at all, and we always have to play these catch-up games, which we create a new technology, and then we have to mediate this technology somehow. I don't know, but that's basically for me that's the definition of sustainable solution. Personally, I think that, well, let's pat ourselves on the shoulder. So scientists actually done a reasonable job on this, and I think we have enough of good technologies these days, and it's still a question of implementation. Maybe when you start to implement them, you find some flaws there, but the true sustainable solutions now being blocked by implementation rather than by the technology itself, and I think that's where the bottleneck is.
I see. I think that's a really good point about technology and how it translates to potential solution. Well, maybe problems we create for ourselves first, and then that can also translate into solutions later on. So maybe let me turn that a little bit and ask Brian and Duncan the same question, because we had two experimentalists here speaking, and then from more you guys study more theoretical.
I definitely look at things, but
correct. That's true. But so from those more abstract concepts, perhaps, how can we relate that to the ideas of solutions in the concept of sustainability? How do we engage people from communities that perhaps work a little bit more on the abstract, on the more theoretical aspects, and then still channel their knowledge and expertise into generating technologies or ideas that can bring solutions to the problems we face today?
Ryan, you've been looking at the fusion for so many years. Where is our fusion?
It's above us right now, making it 33 degrees outside. It's a great source, may I tell you. I don't have the luxury of ignoring economists because I'm married to one. Economists actually are going to be part of the solution, and I would say a good economist, of which my wife is one, acknowledge there are issues with the current paradigm of growth. And I want you to think, I'm going to do an astronomy thing on you. So we all want, you talked to the Deputy Prime Minister was here, what's a good growth target? If we had GDP grow every year, year in and year out, by 2%, you'd say it's kind of anemic, but I could live with that. All right, 10,000 years, 2% growth. What is that? Well, if you get your calculator out, it's 10 to the 86. 10 to the 86. That's many tens of orders of magnitude more than the number of electrons in the entire visible universe. Okay? So, you cannot grow exponentially, which is what we have been doing for the last 400 or 500 years, without actually changing the way we do things. Okay? So, the status quo will break at some point quite quickly. Okay? 10 to the 86 is not a number to muck around with. You cannot have any coupling to any resources at all with a number like 10 to the 86. And so that's completely different than what we're doing. So my definition of sustainability, and I think I'll express it as an astronomer, as at a very basic level, it's to have a person born today have a path to having a life that I would consider to be prosperous. So I'm going to assume a person lives for 100 years. So I think sustainability is saying we don't have to worry about 10,000 years from now, although we have to acknowledge how things add up. But we need to have a pathway so that people born today can have a life of prosperity. And I'm going to make it as simple as that, okay? That's a big ask. So what we have the opportunity of scientists to do is to think about problems on a 25-year timescale rather than a 3 or 5 year timescale like everyone else is doing. And to solve our problems, we have to think about that. So we have, and Steve and I have been talking about, how do we really deal with energy? I mean, it's well and good to say net zero, but you're going to need actually to create solutions. And the solutions are going to be different in Australia than they are in Japan, okay? And we need to be pragmatic about that. And I think he and I would agree, I do not see a non-nuclear solution for a country like Japan going forward. Now, I can see in Australia, you might not need nuclear, but I just don't see how up in the Northern Hemisphere with small amounts of landmass, you do it. Singapore will have a real challenge of having a long-term solution that is entirely renewable, just because it's the size, Singapore is the size of the town I live in of 500,000 people. It's tiny. So you need to be pragmatic, but it's all sorts of things. So Rich Roberts and I have been working on agricultural sustainability, right? Because right now, it turns out, the world, and no one here probably realizes, except for the few people who are working in this area, the amount of food we're producing and the amount of demand when we hit 10, 11 billion people is on a collision course for famine. And the actual agricultural productivity increase is well short of what is required. And we can see the train wreck coming. Is anyone working on this? Not really. Indeed, we're divesting from this type of research because it's considered not sexy, right? So people like those in this room, we can point that out and we can work on it. And it's an eminently solvable problem. It is not unsolvable. It just needs a 25-year a chance to think about it for 25 years. And we, I think, have that attention span, but unfortunately, most of the world does not. So we can go through, but to my mind, it's going through and systematically looking at the things, being pragmatic and saying, I don't see, for example, how we avoid, over the next 100 years, substantial sea level rise, okay? And I mean substantial. I'm not talking centimeters, I'm talking meters. So what is Singapore doing right now about its beautiful harbor with a couple meters? And the answer is, Singapore is probably the place in the world that is thinking about it. But most places are not. Certainly Sydney is not thinking about it. So we need to systematically go through these things, but it's going to be some ugly, pragmatic answers. And I'm sorry to say things like lots of nuclear power, potentially some form of geoengineering somewhere. I think these are things that are likely going to emerge, but we shouldn't just do them haphazardly. They need deep thought, because you could, as Costa said, create more harm than good if we do it poorly.
Thank you. And Duncan, what do you think? How do we relate these more fundamental understandings to solutions?
Well, I mean, I think what physics has to offer is the twin goodness and badness of nuclear. I mean, I think there's no way we're going to stabilize the climate with whatever, we've already seen that Steve thinks we're going to be at a much higher level of CO2 than the kind of the hopes that people are expressing. We're going to have to adapt to the CO2 changes and the change to the new world, but clearly to help mitigate it, especially since we've got all this AI use of energy coming up, we're going to absolutely need to encourage, I think, small and modular nuclear reactors, which unfortunately we have allowed the technology for the major nuclear stations to kind of die out. We've lost the technology and the people who build these things, really. But I don't see how you can worry about the climate and at the same time say the world's going to end in 10 years or whatever, and say we can't have nuclear power because it's too dangerous. On the other hand, the nuclear power does bring the danger of nuclear proliferation. Everyone is going to, the problem of, is what's blocked us is to prevent plutonium, basically, from proliferating. But I think we need the nuclear, and we have to come up with how to handle non-proliferation, but nuclear is absolutely necessary, and I don't see how we can escape it. And nuclear is coming out of the physics world, basically.
Can I add a little bit to what Brian said? He raised a very important point. First, food production and food waste taken together is about 25% of all greenhouse gas emissions around the world. And it's not only methane, but there's something even more serious. We use fertilizer. The fertilizer not absorbed by the plant is converted by microbes into N2O, which is 100 times worse greenhouse gas than carbon dioxide and lasts 300 years. And so here we are, 8 billion going to 10 billion, and you think you're going to, what are we going to do to substitute for fertilizer? Because we have to increase the productivity per acre. No question about it, but we have a greenhouse gas problem, and we don't have an off-the-shelf solution to replacing fertilizer yet. And there are potential things, but this is something that is, very different. I think everyone on this panel will say you'd be foolish to turn your back on nuclear. It's something we have, and it could be made very, very safe. And the choice is, do I like nuclear? No, I don't like nuclear. I like wind. Sure, you can like what you like, but you don't also want to be in the dark. But these other issues, these very deep issues on food production, are there staring us in the face, and we do not have, and there have to be more people thinking about how we're going to make it more productive and how we're going to turn off the greenhouse gas emissions from all the food production. And it's just not making more polite cows that burp less.
Yeah, and we're going to need GMO food. I mean,
yes.
This whole attitude of no GMO is, again, a bit like no nuclear. It's absolutely going to be necessary to adapt the crops to the changed climate, the changed environment.
And so let me be provocative. We have young people here, and I'm sure we'll end up making the news around the world here one way away. So the GMO bandwagon is one that is, to my mind, irrational, because it literally makes no sense. You are allowed to create something from GMO, and then we have these groups around the world that radiate plants to get them to mutate, and they can kind of recreate the GMO through a process which is considered okay, but you get the same thing. So the equivalent, it seems irrational. But I'm looking for products on the shelf that are GMO because I know they're more sustainable. And so as someone who's a genuine sustainability person, I want GMO products. I want to be able to buy them. I want to selectively buy them. Yet everyone's proudly saying non-GMO. And that's the world we live in. And we're going to have to fix it, because that type of irrationality is going to doom us to not being sustainable.
I'm actually curious, in the audience, among young people, how many people are in favor of GMO crops widely distributed? Raise your hands. How many are not, that don't think it's too dangerous? Raise your hands.
You've just made it so that they would be shaped.
No, you can disagree with Brian.
Brian, okay, let me ask you then the follow-up question. So, okay, GMO crops, I completely agree. Now, the one of the research field which was very popular is the biofuel, and which is of course very unsustainable. There is a problem with that. The only way you can possibly make it sustainable if you develop a new type of algae and just release it in the ocean and use the ocean to grow it. But that requires genetic modification to create new type of algae. Would you be okay with that? Or so and of course, because the next step, what happened with COVID-19, we still don't know what happened with it, but there is a good chance that they've been tampering with the.
If you're asking me, I'm a little bit leery. I mean, people were thinking, the photosynthesis in the ocean is limited by nutrients, and particularly iron. And if you sprinkle iron in the ocean, you can get a bloom of photosynthesis, which captures carbon dioxide. Sounds great, and you can make your mutated. Maybe it can turn into food. But I'm a little worried that you've unleashed something that you can't control. So I prefer to do geoengineering on land in agriculture where it's under control.
In contained. So what, if you're going to go through and throw algae into the ocean, I could imagine it being quite useful, but it is an exponential, uncontrolled runaway, not nuclear, but biological, that will almost certainly make major changes in the ocean and probably into all sorts of parts of the ocean. So that strikes me as something to be extraordinarily cautious.
Yeah, I think we're in violent agreement here.
Yeah, that's exactly my point, that there should be, we really need to take it with a caution that on crop, totally agree, it should be there. Algae in the ocean, I would be very, very, very cautious about this. I can just, as a midlife, as a mid...
Yeah, similarly with terraforming or whatever, to fill the atmosphere with minute dust particles to screen out the sun, I think is a crazy idea, unless we're really...
I think it's not as crazy because you're talking about modulating a few percent and it's reversible. If it turns out there's unintended consequences, the particles stay in the air from Hadley currents for about 2 years and they fall down. And so whether we, and it's been said that if you do geoengineering of particulate matter to change the amount of sunlight by, we're talking of 1 or 2%, it could be more reversible than something you can do with living things in the ocean. And so I'm a little bit more, in an act of desperation, we could do that, and we will be in active desperation in the coming decades.
Yeah, so I tend to agree. I'm not advocating we go out and start launching sulfur dioxide into the atmosphere, because it clearly has all sorts of effects, as near as we can tell, at limiting rainfall and things. But one could imagine moderating, I think, especially up in the polar regions, where you get the natural feedback of creating because, the Arctic, where I'm from, is going to be ice-free here pretty soon. And that is going to further lower the albedo. And so doing something up there strikes me as being the easiest. And there's a nice thing is that the way the currents work around the Earth is if you do stuff up in the atmosphere there, it's kind of isolated. It gets a little meridional zone that kind of holds things there. It's like if you launch a balloon, it always just goes around the Arctic. It doesn't get down south. That being said, Costa's point applies. I'm not eager to go out and just experiment. I'm thinking we at least need to think about it as one of the arrows in our quiver, because I think we could be very, very desperate, as Stephen says, 100 years from now, or likely well before.
So I have to interject here a little bit. Like, who would have thought if you put a few very brilliant people together, a lot of creative ideas will fly. And then we can go on talking about this for a long time. But in keeping with the theme today, I want to just bring that conversation back a little bit, right? So we talked about sustainability in the environmental sense, a lot, right? So one other way of thinking about sustainability, if we zoom back into the people behind it, the scientists themselves, especially for the young scientists here, when we develop our own scientific career, it is a long process, right? It's full of ups and downs. And to make that intellectual journey sustainable and healthy, right? That's another key word in our discussion today, in keeping with the idea of well-being and sustainability for the scientists themselves who are going to contribute to developing all these amazing new ideas and solutions to help the world and solve these problems. What are your thoughts with regard to that? How do we ensure that as a young scientist, our own development, both personally and intellectually, stays sustainable, stays healthy, and we can keep our passion and our well-being at the same time, especially when things are hard. So And perhaps I will start with you, Brian, since you are overseeing the university, right? So you are interfacing with a lot of young scientists and young students who are about to embark on this long and very exciting, but also very challenging process.
So we're at a time of intense change, and I think what I always tell our young budding researchers is you have an entire set of options. When you're going through and you're learning to be a researcher, you're not just becoming the expert in a very small little thing that's your thesis. You're becoming someone who can do a whole range of other things. And so you're building up your options for the future and understanding that success is multifaceted, that you can go and you can take that set of skills you have and do anything that is of worthwhile to you. And it's not just what your thesis was, and it's not just being a university professor. It can be almost anything. And if you have that confidence to know you have options, then I think it's much, much easier to come to terms that you do the best you can right now, and the future will look after itself. Don't try to over-engineer your personal future when you have so many options. Try to do really well, have a 5-year plan, but be prepared to change it. And I think looking after your well-being, if you actually have that confidence in the future, you won't do stupid things like work 90 hours a week and end up giving up your personal life to chasing time in the lab or doing things that are poor for you. You need to know it's a long haul for the rest of your life. Have confidence in the future, in your options, and that's my number one advice to people. Don't think being like us is the only sign of success. I can personally tell you that, winning a Nobel Prize, which seems like about as big a thing as one could do, didn't make me happier. It made my life crazier. It made it, in some levels, more interesting, but it did not make me happier. And I think it's important to people to know that. It's not the key of happiness. It's the key of craziness to win a Nobel Prize.
That's a great point. And treating our career as a marathon, not a sprint, right? And don't burn out along the way.
It's a marathon that does not end until you die, and you don't really think about it.
That's
dying.
very comforting.
I don't encourage you to think about dying. It'll just happen at some point.
Let me maybe take it from another perspective and wrap it back into the sustainability story, and I think so. Just being in the company of the four bright physicists, I should say that scientists are probably the privileged class, and I think just being physics or science student or researcher, professor, whomever, we are probably the only class cohorts of people who are probably should be allowed to be non-sustainable. So let's put the sustainability efforts on the rest of humanity. But if you want to make a discovery, unfortunately, you have to break the rules from time to time. So you are always in some local equilibrium, but in order to find, if you want to find more sustainable solution, you need to jump out from this local minima and think outside of the box and cross this barrier and explore the area around. And unfortunately, from time to time, you have to spend energy, you have to spend money, you have to splash, and there are lots of dead ends. So it's pretty much unavoidable. So I'm quite happy thinking about myself that I do work on some of the sustainable solutions, but I like thinking about myself that I'm given a free hand and to find the sustainable solution using non-sustainable methods.
Does that free pass come only after the Nobel Prize or already before?
Believe me, I've done stupid things even before. So
That's good to know. So what about you?
Well, I think one thing that's as good about sustainable things is the sustainable queue of students who are interested in science still coming in. For a period in the early 2000s, they all seemed to want to go into Wall Street or to finance industry, and the physics enrollment went down and down and down. But at least it's healthy again, and there's enough young people who are interested in passionate by science. We do need a steady stream of people to take over from us in the future.
I'm trying to follow the flow of logic, because I thought we were talking about sustainability for young people and sustainability in their career.
Yeah.
And so I want to go to that part. Science is, if done right, first of all, you should take advantage of your environment. As wherever you are, look around. And you should be socially interacting with your fellow students, with professors, with everybody, and just talking about what you're doing, trading ideas, brainstorming is a lot of fun. What I learned at Bell Labs is you have an environment, there are experts in this and that, and if you have a crazy idea, you say, hey, I've got this crazy idea. What do you think about it? You know, sometimes they'll say that's a pretty stupid idea, or it's been done before. But in some rare cases, they say it's cool. But it begins by sharing an idea. And sharing an idea means you're opening up the kimono, you're saying, okay, and you cannot be worried about, quote, someone ripping you off. But as I've seen people obsessed about that, there are some ethical people in science, but get over that. And what you'll find, it's so much more enjoyable when you're interacting with people and you trust each other and you're sharing ideas and you quickly help each other bootstrap up out of nowhere. And that's, for me, one of the most fun parts about being a scientist is you look around and there are lots of smart people around and share ideas and brainstorm.
Yeah, I think wherever you are, you should take advantage of, seek out the people in your university or lab or whatever. And in fact, the advice I give the young graduate students coming in is to go to as many seminars of different things as possible. And you can always take some work to be sitting at the, if it turns out that you don't understand the words, you can always take your work and be sitting quietly at the back and working on it. But usually you'll get something out of a seminar. And I think the most fruitful way in choosing research directions is actually you move sideways from something you know about, and then you hear about another topic which apparently is quite different, and you see some common thread that possibly you can make a contribution on that. And that's happened to me a number of times in my career, that I've seen that something I know about seems to fit in with something rather different. And that's science has this quite global structure where, basically quantum mechanics for particles and quantum mechanics at very low temperatures. It's all the same quantum mechanics and more general principles of science too. So it's surprising that the same principles apply in rather different areas of physics, and you can make interesting contributions, as Steve was saying, where you might be the first to see a connection, and you can then exploit that and make a distinct contribution in a slightly different area, which didn't know about what you know about.
Yeah, I think that's a wonderful point. I think, Brian.
Yeah, and I think I guess my philosophy, summarizing what you've just heard, is that it's really important, if you want to be well in your pursuit, is that you are doing things through excitement, curiosity, rather than doing things out of fear. So, if you're doing things out of fear, which we sometimes throw you into prelim exams, tenure conversion and stuff, that's never a good place. So always try to convert it into, I have the confidence the future will look after, and go in confidence, out of enthusiasm of what you're doing. Always good. Working under a cloud of fear is terrible. And
especially trying to please your parents.
Or thesis advisor.
Or thesis advisor.
Yes, and actually, I have a question for the audience based on all these great advice. Is like these days, I think we talk a lot about mental health and well-being for the students, right? How many of you have at least some ideas or exposures to the resources you have around you about mental health and well-being in your institutions and your environment? Great. So this is really I think that's a really, really good sign that we're all more familiar with the terms and the resources available and normalizing the discussions of this. So maybe let me just build on that and your advice earlier. You talked about curiosity and passion and how important it is to work based on that. And I think from all these discussions, what I gathered is that for all of you, perhaps one of the many secret ingredients to your successes is that you are always constantly learning, keeping that curiosity going, right? Keeping that spark. So is there any advice or any reflections that you have that you can share with the audience here, the young scientists over here, of how do you really sustain or keep that going, right? Because things can get quite hard. What if you run into the wall 5 times already and you're on the verge of giving up? Like, what are some of the methods, techniques, or in some sense, guidance that you can offer the audience here in terms of keeping that spark going? Maybe, since I've done a little bit of internet stalking on many of you, most of you, I'll direct that question to you because I was very intrigued and excited to find out that you are also very involved in art. Right? Is that one of the ways that you find nourishing and helping you keep sane and keep your intellectual curiosity strong and sustained?
Yes, you just lost me. I prepared a good speech, and now you completely lost me.
Rewind. Rewind.
Right. So, so first, I think it's absolutely correct that the curiosity is the key. So. Fear, peer pressure, popularity, just, it can keep you for a month or 2, maybe half a year, but then it's going to die. So curiosity is definitely there, and it's much more lasting driver for yourself. And of course, I remember myself from my students' years, and you're really scared to miss on something, and you jump into the new topics and into the popular topics. But then, as I do more and more research and publish more and more paper, I understand that I actually understand less and less, because so as your sphere of knowledge grows, this boundary of the known and unknown grows as R² as well, right? So that's and this is probably good, and I'm quite, and from my own experience, you just take a well-known phenomena and then you dig a little bit down and you find that there are so many things which are still not understood or understood incorrectly and could be revisited, that you can pretty much take any topic you like. So in that sense, if your curiosity drives you towards, I don't know, condensed matter physics or cosmology or energy or anything, that's absolutely fine. That you are certain, if you work hard and you're honestly curious, you are certain that to find something new. So we know so little at the moment that I won't worry. So this time in my career, I'm certainly not worried. Just whichever topic of research I take, I'm sure that there will be lots of new discoveries made. So where the next big breakthrough is going to happen, you never know, but maybe it's so not next year. In 2-3 years, it's going to be your time. Art doesn't really help, so I wish it could, but I learned one thing from art, and so it just helped me to understand. So it's a long story. I'll tell it to you separately, but it just tells you that in art you cannot plan to paint a masterpiece today. And I made this mistake and many times, and that you you create something beautiful and nice and you try to recreate it and it doesn't work because it has to be in the same state of mind, and so it's not almost not coming from you, it's coming from somewhere inside of your brain. Same with the scientific discoveries. You can't really plan it, and you don't know where it's going to happen next. So but the only thing that you can do is to create enough prerequisites for this to happen sooner rather than later, and then each scientist would have their own ways how to increase those chances.
Yeah, in some sense, we should just embrace the uncertainty in this process as well.
I think a research career is not a straightforward path, and of course there's a pyramid too. I mean, at some point, many people who study physics, and they wanted to be a university professor when they early on, and it doesn't work out. I mean, it's a question of there's a random aspect to luck, basically, that your path that you chose for reasons that you probably don't fully understand, and takes you accidentally close to some topic that is actually takes off, and you make a contribution to it. And but you're not in control of your research life. You can help to expose yourself to more possibilities by being more outward and talking to lots of people and going to seminars, but nothing is guaranteed. But what we at least claim about physics is the training in physics gives you a training in thinking, and that you can then go out and apply it. And even if you're not, finding what dark matter is, and you're maybe working on sustainability of energy production or whatever in a practical career, you hope that whatever you learned in physics, training and doing a PhD will help you to apply yourself to all sorts of different things. And you shouldn't be totally depressed and commit suicide or something because you didn't get tenure. Right?
And I think it's important to add, even if you're depressed, it's fine, because we can work through that, right? And by talking to people, using the resources we have, and try to work around it or embrace it.
I want to tell you a little bit about, when I go into something new, and I try to train my graduate students and postdocs to do the same. You want to understand something in its simplest, most fundamental terms. This is at the high school, freshman, sophomore level, and work very hard to understand. If you want to go in and read a lot of research papers and you think you're going to a new field, so you're going to sit there and read many, many papers, I found that is frustrating and intimidating and no fun at all. And so you try to distill it to freshman physics, if anything, and once you distill it to very elementary terms, it becomes intuitive. Once it becomes intuitive, it becomes obvious what to do next. And I found that over and over and over again. You just distill it to super, super simple terms as, oh, that's all that is. And so when we're taking apart a paper, in a journal club discussion in a group, it's the same. No. Let's figure out what's really going on at its most fundamental level. If you try to go somewhere at the top, you're gonna. It's very disquieting, and how should I say this? You're on shaky ground, and you probably know that. You don't fully really understand it. And so you're trying to memorize what has happened. And that could be very, very intimidating to you, because you'll know that you might not really understand. But if you understand it like you understand high school stuff, and you can explain it to anybody at any level, at the high school level, then you're quite content with it, and you don't feel intimidated. And the intimidation stuff is when you try to read a lot of papers and learn it that way. No, just get a glimmer of what they're thinking about and figure it out on your own. And yes, even go to Khan Academy. It works.
ChatGPT these days fill in that role for a lot of students. Oh no, I said the forbidden word, Brian.
Yeah, the problem with ChatGPT is it gets a lot of it right, but occasionally gets things horribly wrong and can send you the wrong direction. So I guess just as a nuts and bolts, the way I deal with starting challenging things, and I'll comment, I mean, Steve has just kind of said the way I do things as well. But when you're working on things, there are times when you're beating your head against a brick wall.
Yeah.
Now, sometimes that brick wall is actually illusory. It's something you're going to crack through. And sometimes you've decided, for whatever reason, to, as your PhD thesis, to unify, to do quantum gravity or something, and you're not going to solve it because it's too hard, right? So what I always suggest to people is when you get stuck and you're beating your head against a brick wall, you want to keep beating your head against a brick wall because you're going to have to figure out, talking to people who are wise, whether or not it's an actual wall you're not going to get through or it's just hard. But you can't do that, just day after day after day. You're going to have to do some other things. So I think you heard Rich talking about having a plan, like kind of a side project, having a project that you can spend some time on a bit where you make progress. It may not be super exciting, but it's a place where you're making progress. That's one thing that I like to do and go that. I think going out and learning new things, and when I learn new things, I do exactly what Steve just talked about. I don't go and just start reading the papers. With the way everything's on the web, you want to look for really good physics colloquia that are out there, the best ones, because they will take you, a really good physics colloquia, take you right down to that high school level, and they've done all this work for you, and you can listen to it and find 2, 3, 4 of them and learn something new, even if it, just whatever. It's anything to keep your mind going, make you feel like you're making progress as you then spend some time to, bang your head against the wall. And then at some point, it's good to simply disconnect, take some time off, right? I mean, how many people in the audience have actually taken all of their leave in the last year? I haven't. Yeah, not very many of you. Okay, it's okay to take leave, and I really think it's good to take leave and do something like art, or in my case, my winery or whatever, where you just kind of decouple and take some time. Don't be worried about that. But you do need to have that energy to, keep banging your head against hard problems. And at some point, you realize they're too hard, and you need to switch into something else. And that's the wisdom that comes, I think, as you get older, is realizing when problems are too hard. And that's where you want to talk to other people for some advice on that.
I just want to say, Brian, that what you're saying now is a little bit more than a social advice, because that's exactly what works for me as well. So you bang your head against the wall and it doesn't work. The best thing you can do is to leave it for time being. Maybe do a side project, do something else. You can't imagine how many solutions just came to many people, including myself, just in your dreams. Because when you stop thinking, you stop thinking about this, but your brain somehow keep working on this, and that's I would like to. I'd really love to bring it one day as a scientific project, because how do you actually solve problems? Because how much of it is conscious and how much is beyond your consciousness? And for me, it's actually, I think it's quite a large chunk which is being beyond your
I solve a lot of my problems in the shower and in the vineyard because I'm not thinking about the problem, and suddenly, that's how I solve it. I don't know. It's just weird.
I want a vineyard. And for me, exercise is a big part of what I do. And bicycle rides, I go ride up a hill for an hour and you think you're sucking air. You're just, and you come back and sometimes lots of problems are solved. And so whether it's a shower or exercise or something, but I would also advocate exercise is also really important. It's very highly coupled to mental activity as well. And so a lot of people I know, they somehow get a lot of cardiovascular work in somehow, because it's really very connected. And so if you get too bookish and say, no, I don't have time to exercise or do sports. Or you don't have to do sports. You know, you do grunt sports like just bicycling or jogging or walking. But you know, I advocate to all my people, you know, do something with your body as well.
I can see the four of us in Lycra following you and the bicycle path around Singapore.
And I wanted to ask, do you do winery or you actually produce wine? Because those are two different things.
I do both. I produce the wine, but there's a lot of work. I was digging up rabbit holes the day before I got on the plane here, so that was my exercise.
And I drink wine.
All right, yeah, that was my next question. Do you do winery, produce wine? Do you drink wine? And where is our bottles?
Ask Singaporean customs officials about that.
Brian, next time I'm in Australia, I'll have to visit your winery.
Actually, when you're hitting a brick wall and things, just the fact of having to do teaching duties is very useful, I think. I mean, just in Princeton, at least, we have to cycle between the advanced classes and Newton's law, basically, and take a share of these things. And just trying to explain Newton's law and stuff like that can often trigger something in your how to get around the problem you're on. So just your brain doing something other than bashing against a brick wall is the way that often can stimulate you to see your way around. And also talking to people a lot. For me, at least, it's crucial to grab people, buttonhole them, and probably waste all their time by explaining the problem that I'm stuck on. But physics is a really social activity. I think it's very difficult to be Einstein sitting in the patent office and doing it all by yourself. Maybe for Einstein that's okay, but for most of it, I think just explaining your problem, listening to other people's problems, and just generally gives you is the way you kind of know what's happening and gives you ideas. And it's really impossible, for me at least, to make any progress without talking about the problem again and again to lots of different people. Luckily, we have all visitors who come through at a place like Princeton, but most people will have visitors coming around in their institution, and you get a bit of a time with them. Yeah.
And even Einstein had to go out and talk through general relativity to Hilbert.
Yeah.
And Hilbert, maybe most people don't realize, that actually published the solutions to general relativity a couple days before Einstein.
Yeah, right.
Because Hilbert was a much better mathematician than Einstein.
Yeah.
And Einstein needed his college friend, Marcel Grossman, because Einstein cut all his math classes when he was a student. It really pissed off the people at ETH. And when he was stuck, he was good enough physicist to realize he didn't actually, to generalize special general relativity, he didn't have the right mathematics. And his friend says, I think Riemann did something you would be very interested in. And he realized, my gosh. So he actually talked a lot to people as well. The myth he's sitting there alone. He was, you probably all heard of all the dialogues and debates and all this Kwame. He was actually a closet social person.
Thank you. This is a lot of wonderful advice, and I think if I may attempt to summarize a little bit, I think the key takeaways I had is that science is a very social discipline. I think we don't want to be alone. We want to talk to people, take breaks, find a personal hobby project that you can take we can take our mind for a rest, but also allowing it to have the space to generate and create new solutions to the problems we're facing. So I think these are really, really useful and wonderful advice. Having had this very privileged time to ask the questions that's very close to my heart in this discussion, I think it's time to open up the floor for the audience to ask some questions. We have about 20 minutes or so. So if you have a question for our panelists, please just go to one of the two mics, and then you can just queue up, and then we'll take the questions one by one. Okay? So I think maybe first one over here, and then the gentleman over there. Yeah.
Perfect. Thank you very much. Thank you, speakers, for your really insightful talk. Regarding human well-being, I think our perception about the world around us is really important. And as science advances, we'll be able to create some entities that are non-biological, but can actually autonomously do some task, and such as the really tiny robots that can clean out blood vessels or AI. It seems like they have the mind of their own. So my question is, where should we draw the line between what we can call actual living things and something that are not? Thank you.
Tough question. Who's going to take it?
You work on it.
All right, yeah. So just let me start, guys. But then I need your help. So, well, first, I don't think we need to be particularly worried about this, and especially as scientists, we need to jump on this opportunity and try to understand it as much as we can, and then the definition of what is living thing, what is non-living things is of course very much depends on what you're doing. So we're trying to call our materials living materials, but it's only because they locally and temporarily can break the second law of thermodynamics, which is already quite a lot. And then of course for biologists, self reproduction is a big thing. But also people work on the synthetic biology and on those things. So whether we should be worried or not, I frankly, there is a simpler answer to this, probably, that I don't think we have a choice, because as human beings, you can't stop thinking and you can't stop discovering. So I think that there should be some fundamental law which would tell you that it's fundamentally impossible. It's like your brain keep working on the subconscious level, that if the discovery is meant to be discovered, it will be there. And just more practical on AI and so on. We work a lot on AI, and I've got very mixed feelings. So my enthusiasm goes up and down, and it's but we actually do quite a lot of work on material discovery with artificial intelligence. Whether it will be able to replace a scientist, well, I think it will be able to do a lot, but maybe not to replace a scientist with the scientific discovery, because the scientific discovery is always a phase transition, and I think AI is fundamentally bad to predict or find the phase transitions.
Well, yeah, I think if AI had existed in the 1600s or whatever, AI could have certainly discovered Kepler's laws, but I don't think it would have discovered Newton's law.
Well, I mean, I guess I see whether or not there's a definition of life or not, I think is that I don't care about. What I care about is whether or not all of this technology is helping what we described earlier as my definition of sustainability. Is it helping people be better over the next 100 years and there beyond? And what AI can and cannot do, what technology can and cannot do, will be revealed over time. But we do need to make sure that it is in service of humanity. And I think there is a chance that we could lose control of the technology in a way where it doesn't serve humanity, maybe because only a small number of people are in control of it or things. And at some point, you then have to regulate it. And I know Costa says you don't regulate science. Well, we do. You're not allowed, Costa, to build a nuclear bomb. Not allowed to do, bio weapons and things like that. And
nuclear bomb is not a science; it's technology. The knowledge cannot be restricted.
Again, the knowledge of how to build a better nuclear bomb is not something, I promise you, if you start working on it, you're going to be visited by people who are going to complain. And so there are restrictions on what we do. And I think AI is going to face that probably pretty quickly unless we self-regulate where we're doing it in service of humanity.
Okay, maybe let's move on to the next question over there.
Hello, thank you for this panel. A question regarding the transition, as Professor Schmidt emphasized, the 25-35 years ahead will be critical. And as an economist, the best way we use actually, or we found to look at the future, is to look at the bank's balance sheets And the bank's balance sheets nowadays, they are not very green. And that might be an issue because today's loans are actually tomorrow's investments, infrastructures, facilities. And if you lend, for instance, in oil and gas, you don't want it to collapse in the next decade because otherwise you will have actually financial stability issues. And in that perspective, as policymakers and top scientists, do you perceive actually the financial sector as the last fortress science has to conquer, I would say, like a conservative stronghold that needs to adjust to finance the technologies and infrastructures risky but required for the transition? Or do you see the financial sector as the mirror, I would say, of societies that are overall reluctant to adapt to the new challenges?
Maybe we start with
Well, I can start, and then I think Steve has to say something here. So financial markets operate in our society under a regulated environment. It's not laissez-faire. So if we were to, for example, put a global tax on all the greenhouse gases and build that in, then the markets are going to react. And think of the markets as, from my perspective, as a way of optimizing against a set of rules. So I think it's up to society and science to inform society about what the regulatory environment is, and then to enforce finance to work within that. So if we make the decision that we're not going to put a price on CO2, for example, that we are going to allow capital to flow to giant entities and not do a return on labor, which is what the current settings are, there are going to be consequences which don't look good to me. But the financial markets, to me, are kind of a giant set of things to optimize against a set of rules. And I don't see them as evil. I see them as a tool that we have in our economic system of the current world to optimize. Nothing more, nothing less.
I'm actually slightly unsure of your questions in terms of what were you saying about. Could you repeat your question again?
Yes, so regarding financial markets, it was not to describe them as evil, but more as conservative. So, because at the end of the day, there are people behind trying to optimize their organization, potentially the return of their corporates. But these corporates will have a huge impact in the future. So do you see these corporates as a potential brake for the transition, or do you see them as an adjustable organization that will anyhow adjust to the society they are serving? So do you see them as a proactive brake, or more like just a simple mirror, and the challenges are actually lying somewhere else?
Okay. So in the pure financial, I agree with Brian. In pure financial market, you want to optimize return on capital, and mid long term everything. It's not, but if left to its own devices, experience has shown that just optimizing this leads to some very bad outcomes. It leads to things. It leads to financial collapses. It leads to fraud and all sorts of other things. So they are very regulated because of those things. And so given that, and so then now, then is it, I just view it, and you say you still want to optimize. Here's a real application. One of the first applications of AI machine learning is actually in the, as you probably well know, is in the financial markets. And there's tons of money going into this because they're realizing that you can further optimize, but further optimize within certain boundary conditions. I regard the financial markets in forms of capitalism as kind of, it's not immoral, it's amoral. And so if you want to put something, so it's up to society to say, this is where we're heading, this is what we have to do. We have to look out after all of society and not just maximize the profits of one organization. And so I don't know if that helps clarify something, but it's you with your boundary conditions, you want to optimize this, but same with scientists with their boundary conditions, they want to optimize their careers as well. And it's not, and that's definitely not an immoral thing. So I don't know if that answers your question.
That's very clear. Thank you very much.
All right, we move on. Let's move on to the question here.
Okay. Hi, my name is Revati. I'm a PhD student, and I just want to thank all of you for your very candid conversations. I think one important reminder was how when you guys actually allocate time to exercise, I think I have no excuse to not exercise. So thanks for that. But what I wanted to ask is PhD students, we are all very much dependent on our PI to provide us the guidance and kind of lead our path the whole period of like 4 to 5 years or so. And many of times, like our PIs do not have a very good expertise of what we are trying to do, and sometimes they just don't have the time to guide us. And a lot of times, some of these PIs are so driven in terms of their results and publication that they don't exactly align with what the student really wants to do. In this case, like how do PhD students kind of still find their place in this research arena and really find their path? Thank you.
Let me start first. My advice is you may have the wrong PI. I think the right PI is someone who wants to nurture you in your abilities to best, and they're not trying to use you to advance their career. Their primary job is to train young people in the direction they want to go. And so you want to have a PI that's very supportive in that respect. And so I was very lucky to have a great PI in that respect. Choosing a PI is almost important as choosing your parents.
No choice.
And if you find that your PI wants to use you as an instrument for their own ambitions alone, and they're not looking out after your welfare, get another PI.
I just want to clarify that this wasn't directly talking about my PI. But just
in the abstract.
but I just want to clarify, just like how we don't really have much control over our parents, a lot of times students are kind of don't have much of a choice when it comes to the time where they pick their PI, just because of funding issues, or sometimes they just have a time constraint that they have to work with. And in those situations, is there something we can do to still make things better for ourselves, like to still be focused on our passion and driving towards our future?
I think you have to find it in yourself. You can't rely on your advisor to pump you up with everything. You just have to use your advisor as a resource. And they maybe provided you, from the funding or whatever, but you need to find it in yourself. You can't rely on and also I think you should look for mentorship in a wider context. In whatever institution you are in, you should seek out and make connection with people who can mentor you to some extent or other, and learn from them. I think just because you should not be only interacting with your thesis advisor, who may be great or may be preoccupied or whatever, but it's your personal responsibility to find your way and to make the best use of the resources you can find around yourself in whatever institution.
To reinforce that, remember, we've also said, you talk to your fellow students, you talk to your friends that are not necessarily in your field, and it's the social interaction. And so you can't rely on just one person to guide you. In fact, that's a skill in your future life as well. You can't be dependent on one person, your boss, or even two people. You want to create a network, and it's much more fun. As stressed repeatedly in this conversation, science is a very social endeavor.
I think
you want to learn but not be spoon-fed.
At a PhD level, you're probably more than intelligent to read other people's papers, and if there is something unclear, it's your job to challenge your professor, and then. But what you learn, you don't use your professor as encyclopedia. So for that, you can go and read papers. What you try to learn from your professor is the way of thinking and the way of creating new ideas. That's something which you can't which they can't teach you in the university. That's what science is about, and that's exactly what you're trying to learn as a PhD student from your professor, how to generate new ideas and how to find and discriminate between different tasks and discriminate between different models. So the task of the professor is to teach you to do science, not to give you information.
And if I may, oh, sorry.
Your advisor will probably be very happy if you actually find something interesting through connections and bring it to his attention. I mean, that's if the student comes and tells you about something very interesting they've heard about, especially that you haven't heard about, that's actually one of the more satisfying things in interacting with your advisees.
If I may, actually, just to add here, so as a relatively new PI, I think it's also a two-way street, that if you feel like you are not being looked after or you're not getting the right support or guidance, it's very, very important to articulate that, because like you said, many of the early career or very established PIs, they are busy. They have many, many things to take care of and to look after. So without the notion of one student or some students need adjustments in how they've been mentored or what kind of interactions is appropriate, it's also very difficult for the PIs to calibrate. So I think the communication is extremely important from both sides to at least set expectations of what kind of guidance, in what format, what frequency is needed, and what kind of support will be most healthy. And I think I can quite safely say, and I think the panelists would agree with you, when we got the job as a young professor, nobody tested us on our management skills. Right? They checked how many papers we published, what scientific ideas we had, but nobody prepared me or taught me how to manage a team. So a lot of this is also trial and error, and I think that's why the feedback from the students is extremely, extremely constructive and useful for us to improve along the way as well. And I think,
if I can add just one little thing, I mean, I agree with everything that's been said here. It is whether or not sometimes you get a dud professor as your person, and such is life. But you really need, in a PhD, to be able to make progress on your own. And so young PIs often tend to over-service their students, give them too much help. I did that, absolutely. And everyone was happy, but it wasn't good for the student. So if you have a good or a mediocre, or whatever you think, at some point you really need to go through and use the network of students and young staff members and other professors to make progress yourself. That is what a great PhD looks like. And so your prof hopefully is there to provide some wisdom and align, and most people will be able to do that. But I think those who have a great person, but if you're only working with them, that's a mistake as well. So make sure you go through, even if things are easy, and work with fellow people to have a certain resilience and make progress on your own.
Thank you.
I certainly had the great fortune to have an advisor, Phil Anderson, and he never helped me at all with my work at all. He pointed a problem at me, and I was writing some lecture notes he'd done on a precursor problem, and then he went off. And when I got to see him, I would go in and I'd like to talk about some technical things, and he would just tell me about what he was thinking about. And that was an incredible education. And so the best kind of way to advise a student is not to spoon-feed them at all. Point them at a problem and have them come and give them some, maybe a little bit of guidance and things. But the main thing is you need to find it yourself.
thank you for the question. I think it really struck a chord with all the panelists. So let's move on to our next question on that side.
Yeah, thank you very much for the great discussion. I think I pay more into the sustainability question. With the areas we work on, we are probably more inclined to talk about technical solutions. But I'm very puzzled with what Dr. Bryan said about the topic of growth. So one key problem is the growth, because when we have more technologies that produce more energy or reduce CO2, what we would probably basically do is just produce more and more things, and then we have more resource usage. And I also found some research saying that there's no such thing as sustainable growth, and there's no magic technology that would solve the whole climate change problem. And also interesting, what I found also is that actually also growth and money is not always related or not correlated kind of with happiness. So what's basically boiling down to is I was wondering what you think about that, and what could be an alternative system to live in what we are currently having. So sorry, it's very far-reaching, where we have no growth but could still live happily and maybe a little bit longer on this great planet.
So let me start. Right now, if you ask government officials and most economists, they say the measure of the wealth of a society is the GDP per person. And the GDP is actually measured in stuff. How do you increase the GDP? Well, having one car per family, you have 2 cars per family, or instead of one home, you have 2 homes, and you just consume more stuff. You make more stuff, you consume more stuff. And so the GDP as the metric for what's going to make us happy, I think Robert Kennedy Sr., not the junior, said very wisely, there's a quote, and I'm just going to paraphrase what he said. He said that GDP, it doesn't actually measure the things we value. The strength of our marriage, our relationships, the loyalty, honesty, all these things. It measures none of that, and so how do you actually get a different metric than GDP? When I was in the government, I was talking to the economists and said, we need something different. There's a thing, a human development index that includes GDP, status of education, average education in the country, and longevity. That's beginning to go there, and the economists in the Obama administration said, you're making this too complicated, Steve. GDP is a fine metric. And I still, even then and even more so today, said, no, we really have to develop a different metric. You can't talk about sustainability that's built on making and consuming more stuff. Build a building, tear it down in 50 years, increases GDP. Sadly, even wars increase GDP. So we need a different metric. And you have to start with something like that of what do we really value, what really makes us happy. Security, we want to have children so we can throw them and they can walk down the street and you don't have to be worried about their safety. You want food, shelter, beyond those things. You don't want your country to be invaded. You don't want all these other things. And you want to live happy, connected lives and a healthy old age. GDP only captures some of that. So I would say start with the metrics first to really rethink. There will be no true sustainability anyway, but at least you'll make the resources last longer.
Yeah, I mean, I've been discussing this with my wife quite frequently, and it's a problem that needs to be figured out by economists, and they're nowhere close, and they're going to need to sort out. A few reflections. One, if we get to peak population and get into what I would describe as the Korean regime, we're going to have a new problem with sustainability, which is we're going to exponentially decay such that in 200 or 300 years, we're not going to have critical mass anymore as humanity on the planet. Okay, so it's that will solve this problem for us if we don't keep our fertility up somehow. And right now we're on a path that we could easily die out, and we will intervene somehow. I have no idea. So things get a lot easier when we get into everyone having fertility rates well below 2, because it's exponential decline. 2, as a person who spends roughly $200,000 a year, I have everything I want in life. I have no interest in having more, and I don't think I'm that weird on that. But I do need change. And so I do think we're going to need things to change, but not necessarily to have GDP go up to be happy. The problem we have is that not everyone in the world has $200,000 a year. We have a lot of people who have $150 a year. So it's about homogenizing affluence in some way, that we have a way to potentially get into some sort of new sustainability growth. Because I think at some point, when you have enough, you have enough. We struggle in our family these days to give Christmas presents anymore because we already got everything we want. There's nothing any of my kids or me want anymore. And that's on $200,000 a year, so about 3 times the average US income. So I'm not convinced it's hopeless, but I do agree economics needs a lot of reform to sort this out. And they're not even at the beginning of it yet.
Okay, so I think in the interest of time, let's cover the one last question. There was a lady waiting over there. We can take your question and then we'll wrap up. I think we'll be okay.
We will be very quick in our answers.
Yeah, it's a short question, maybe just like short answer, but we'll still cover it.
Okay, thank you. I wanted to ask your thoughts about improving sustainability in research itself, because I'm thinking about all the waste in terms of generating huge data sets that we don't actually fully use, or all the single-use materials in labs.
Great, and maybe that's a quick answer that
I'd use
we
economics.
can be provocative here.
You price it. We have a certain amount. You tax the waste and let us optimize. But I don't think if you have a set of rules and say, all right, physicists no longer allowed to travel on airplanes ever again, then the problem is, as Costa said, we have to burn some energy to find the solutions. But we do need to, I think it needs to be constrained. So we need a way to optimize, and I would use an economic optimization, as unpopular as that might be in this audience.
I think the biggest driver is bean counters and university administrations want to see lots of papers generated, and many of these papers are not really, shouldn't be published, and I think you want to find a wise administration that values, very, very valuable things, and it doesn't even have to be every year, let alone a dozen papers a year. And so that generates more waste than just about anything, is the need to be on this treadmill and produce stuff.
So your citation index has a negative factor where every junky paper you put there puts you backwards. So you've got to work on quality, for example.
Yeah, when I was young in my career, I was about 40 or so, and I got a major prize, a first major prize where they wanted to put all my collected works in a bound volume. And so I had 7 papers. And so I said, here's the 7 papers. And he said, no, we want all your collected works. Those are my papers. And then Art Shallow, who's a very wise, he was co-inventor of the laser, a colleague of mine at Stanford, he says, Anderson got his Nobel Prize with 1 paper. 1 good paper every 10 years is enough.
Okay, I think that's a great note to end on. Thank you very much for the insightful discussion and touching on so many different topics. I think we all appreciated it.